Around 3.5 billion years ago, the Earth was a very different place. Oxygen was extremely low, the ozone layer didn't exist yet, and the planet's surface was constantly blazed with radiation. Were a human being to be transported back there, they would die within a minute. But life still emerged. Tiny unicellular microbes forming the basis of everything to come. Today, we still have much to learn about our own planet's early years, and yet there are some who say we should be looking elsewhere in the solar system if we want to truly understand. Mars, like Earth, is roughly 4.5 billion years old. It formed, along with most of the rest of the solar system, out of an ancient swirling cloud of dust and gas, at a time when the universe as a whole was about 9.3 billion years old. Mars is also a rocky planet like Earth, and it's the last of the inner planets closest to the Sun before our particular star system is split in two by the asteroid belt. In some ways, Earth and Mars aren't so different, but in others, they're poles apart. Mars is around half of Earth's size, it barely has an atmosphere to speak of, and it doesn't have a magnetosphere. Crucially, it isn't within most estimates for the habitable zone around our star either. Not that this has stopped us looking for and dreaming of life on Mars in recent years. The archetypal alien from Mars has been a pop culture science fiction mainstay for years, but actually science itself has moved on. Today, rather than scanning the red planet for an alien colony that's alive and well, our rovers and orbiters are much more likely searching for signs of ancient life, from a time when Mars perhaps wasn't quite so hostile. We may yet find an environment hosting life today, but if not, then evidence of life that once was is the next best thing. The question of whether life on Mars, if it has ever existed, could have predated life on Earth was arguably first asked in earnest in 2013. Back then, NASA was busy analyzing streams of data from its Opportunity and Curiosity rovers. Among many other things, the vehicles found solid evidence whilst digging in rock that Mars had once hosted large bodies of liquid water, and also that it is and was home to many of the most essential elements needed for life. This information has led to theories that microbes may have once existed on our neighboring world too, as they do on our own. Precisely when this period of possible habitability might have been is still up for debate, but many scientists and researchers place it somewhere between 3 and 4 billion years ago. Within the same distant window, then, that the earliest life on Earth is thought to have spawned. Before the rovers, though, there was Allen Hill's 84001, a piece of Martian meteorite found in Antarctica in the last week of 1984. It's thought that the rock, which weighs a little over 4 pounds, crashed into Earth some 13,000 years ago. The leading theory says it was ejected from Mars following another impact event on the red planet about 17 million years ago. But significantly, this meteorite can be dated back a little over 4 billion years in total. That's long before even the upper estimates of unicellular life on Earth. Which is interesting because Allen Hill's 84001 also formed the basis of one of the first major news stories pertaining to evidence of life on Mars. Early study found what appeared to be tiny microbial fossils in the rock. And while these observations were eventually rejected by most astrobiologists, the hubbub was enough for former US President Bill Clinton to make a televised speech in the mid-1990s when analysis from the meteorite was first made public. So that's now a seemingly dubious rock found in Antarctica and some arguably more compelling findings from rovers on the surface, both hinting at the potential for life on Mars up to 4 billion years ago, possibly at a time before even life on Earth arose. And there have been other studies pointing to similar conclusions too. But of course, it's imperative to keep in mind that so far, we still have no solid proof of life on Mars at any time. We only have basis for various theories. But what would the planet have been like so far back in history? As much as Earth was a very different place billions of years ago, so too, it seems, was Mars. When we think of it today, we see stark, barren landscapes layered with dust and stripped of atmosphere. A merciless world without air to breathe, soil to grow, and with precious little hope for survival. But just as we now suspect there to have once been lakes and pools dotted across the Martian surface, we also believe that it did once host an atmosphere, and that it wasn't always so bare. Scientists estimate that up to 66% of the Martian atmosphere has been lost since its height around 4 billion years ago. One co-authored study appearing in the journal Science in 2017, for example, outlined how the planet underwent a, quote, transition in climate from an early warm, wet environment to today's cold, dry atmosphere. That study made use of the Mars orbiter MAVEN to measure upper atmosphere levels of argon in particular. But those behind it say that the findings can also be applied to carbon dioxide levels, and therefore the presence of greenhouse gases on Mars, as well as oxygen. At one time, these gases may have been far more abundant on Mars, again leading to speculation that life, and especially microbial life, could have once thrived there. Even today, Mars is still losing its atmosphere to space, with more and more particles escaping with every passing minute. But it's thought that the majority of the loss did take place around 4 billion years ago. And as for the relatively short time between then and when the planet formed, we're currently not overly confident as to what conditions were like. Naturally, though, it's this unknown period which most fuels the majority of life on ancient Mars theories. So let's imagine, for the last part of today's video, that life did once exist there. What could that mean for us? In August 2020, a familiar astrobiological theme made headlines once again: panspermia. Panspermia is the proposed passing of biological material from one planet to another in a number of ways, the most often cited being by spacecraft or asteroids. The 2020 story centered on a study conducted by Tokyo University and JAXA, the Japan Aerospace Exploration Agency, in which scientists put dried bacteria into exposure panels on the outside of the International Space Station. 3 years after doing so, they checked to see whether any of the bacteria had survived, and incredibly, most of it had. The bacteria on the outermost layer did perish, but underneath it was still alive and well. We know then that in at least one case, microbes could survive in space long enough to make a journey between Mars and Earth. Lithopanspermia, more specifically, is the preservation of cells and microbes in rock, such as inside an asteroid. And we do have various examples throughout our history of Martian rock breaking away from its parent planet and ending up embedded in our own, including Allen Hill's 84001. And so herein lies the next question. If we ever proved that there was life on Mars before Earth, then could that life have been transported here? If you were to trace us back far enough, could we be the product of one-time Martian biology? Importantly, again, panspermia is not a proven process, and a lot of the time space agencies are actually more concerned with how we could be the ones facilitating it the other way, by contaminating other planets with bacteria carried by our probes and rovers sent across the solar system. But it does prompt us to consider space in a wholly different manner, to see it as potentially a vast ecosystem of its own, where life isn't only confined to Earth, it just so happens to be here in abundance right now. Mars certainly has changed over time. We know this thanks to an increasing number of studies. But could everything about us really have started on a different planet? Fortunately, our interest in Mars is far from slowing down. In fact, it's gathering pace as we move through the 21st century, which means that if there ever was life there, then the signs will become clearer and clearer.
The Sun's gravitational pull stretches out much further than Neptune, all the way out to the Kuiper Belt and beyond. To these dark and mysterious satellites, the Sun is just a pinprick in the sky, and one of the most mysterious of all is Pluto. Once classified as the 9th planet in the solar system, in 2006 Pluto was downgraded from planet to dwarf planet. To count as a planet, the International Astronomical Union decided an object must have cleared the neighborhood around its orbit, which Pluto has failed to do due to its relatively small mass. Technically, Pluto is a trans-Neptunian object, drifting through the Kuiper Belt. It was the discovery of another such object, Eris, that led to the definition of a planet being changed. Pluto's surface area is only 3.3% the size of Earth's, making it about the same size as Russia. On top of being small, Pluto has incredibly low gravity, so little that you'd hardly even notice it, about 6.3% the strength of gravity on Earth. Nonetheless, it does have its own moons: Charon, Styx, Hydra, Nix, and Kerberos. The largest, Charon, wasn't discovered until 1978, almost 5 decades after Pluto itself was found. It's large enough that Pluto and Charon were almost classified as double planets. The two are tidally locked, always presenting the same face to one another. Charon's pull causes Pluto's football-shaped moons Nix and Hydra, and possibly Styx and Kerberos as well, to wobble as they rotate, caught in a game of gravitational tug-of-war. What little data we have about this was gathered by the New Horizons probe in 2015, and we likely won't know more until we can investigate further. Considering the fact that we've detected planets and stars and black holes millions of light years away from Earth, it's strange to think that there are so many things we don't know about what's hiding in our solar system. For thousands of years, we didn't have any way to study celestial objects apart from the 7 classical planets: the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn. Obviously, we now know that the Sun and Moon aren't planets, but this ancient definition of planet refers to objects visible to the naked eye. Until the discovery of Uranus in 1781, which was initially thought to be a star, we had no idea there were even more in the solar system. It was over 60 years later that Neptune was discovered in 1846, and in 1930, astronomer Clyde Tombaugh found Pluto. The existence of an additional planet had been hypothesized before this, thanks to apparent perturbations in the orbit of Uranus that was later attributed to an overestimation of Neptune's mass. Pluto may not be a planet any longer, but its discovery was still hugely important, since it was the first trans-Neptunian object we ever found. It wasn't until 1992 that the second, Albion, was discovered. Part of what makes studying Pluto and other trans-Neptunian objects so difficult is the sheer distance between us and them. The distance between Earth and Pluto ranges between 2.66 billion miles to 4.67 billion. For contrast, Mars is sometimes just 34 million miles away. The vast distance makes sending probes to Pluto and potentially going there one day incredibly difficult. If you miss the optimal launch window, you could end up almost doubling the distance you had to travel. And considering that Pluto takes 248 years to orbit the Sun, you'd be waiting a long time to get a second chance. In fact, Pluto hasn't completed even half of its journey around the Sun since it was discovered. The only man-made object to have reached Pluto so far is NASA's New Horizons probe, which in 2015 conducted a flyby over the surface. It discovered a surprisingly youthful surface and varied geography. This included exotic ice flows, mountain ranges, and possible evidence of cryovolcanic processes. A vast haze hangs around the planet, the result of sunlight breaking up methane gas particles. Pluto's plains are mostly nitrogen ice, but its mountains are water ice with methane frost. A dark reddish band named Cthulhu Macula swirls across its surface, possibly the result of organic compounds called tholins, formed when ultraviolet light strikes methane and nitrogen. Perhaps the best adjective to describe Pluto, apart from distant, is cold. Pluto has an incredibly low surface temperature, going from minus 369 degrees Fahrenheit at its warmest to minus 387 degrees at its coldest. While this is still warmer than the average temperature of outer space itself, which is around minus 454 degrees, it's still significantly colder than the coldest temperature ever recorded on Earth. That was minus 128.6 degrees Fahrenheit, recorded in Antarctica in 1983. So Pluto is around 3 times colder than the Antarctic at its chilliest. For more context, liquid nitrogen is about minus 320 degrees. Even at its warmest, the surface temperature of Pluto is still cold enough that if you were exposed to it, you'd freeze almost instantly. Pluto is clearly one of the most inhospitable places in the solar system. Living there would involve the same problems as living in an Antarctic outpost or the International Space Station, only worse. Astronauts and Antarctic residents, who are mostly scientists and military personnel, are incredibly isolated and can't remain in their respective bases for long. The ISS also has radiation to contend with, which, combined with low gravity, is one of the biggest reasons that the time astronauts spend there is restricted. Deadlier still, Pluto's atmosphere is made up largely of nitrogen and highly poisonous carbon monoxide. Needless to say, our technology would have to improve drastically to get people to Pluto in the first place, let alone to set up some kind of outpost, or to have any chance of a return journey. It's unlikely that Pluto would ever become more than a research base, even in an advanced future, much like Antarctica, though it might see the odd tourist. It would just be too difficult and risky to build any large-scale settlement with any purpose except studying the planet, or perhaps refueling spacecraft if they journey further out. But perhaps Pluto isn't as bleak as it seems at first. There are many icy worlds in the solar system that we think have subsurface oceans, such as Jupiter's moon Europa and Saturn's moon Titan. Europa is much closer and is most likely hiding a massive, warm ocean beneath its frosty outer shell. Some scientists think that Pluto could be the same. A large basin of frozen nitrogen and carbon monoxide ices was spotted on the surface, which shouldn't have been able to form without an ocean underneath. This evidence confused astronomers for a long time since they couldn't explain how Pluto could have an ocean, but new theories suggest that Pluto might have a layer of insulating gases that keep it warm enough to harbor a vast alien sea. If this is true, not only could there be alien life on Pluto, but we may be able to send humans there one day. Luckily, by the time we develop the technology to get there, we'll probably already have explored Europa, so we'll have valuable knowledge to draw from when it comes to building in this kind of environment. However, Pluto is still incredibly far away from the Sun, which could be enough on its own to prevent life from evolving. Pluto is so far away that it's hard to know for sure whether it's a desolate, dark wasteland or a secret haven for aquatic aliens. But until technology gives us the answer, we can at least dream of the latter. When it comes to human colonies in the solar system, Mars is usually billed as our best bet because it offers some favorable conditions and isn't too far away. But the red planet isn't without its share of problems either. There are other solar system places that we could even be better suited to. The Galilean moons, Io, Europa, Ganymede, and Callisto, are the 4 largest of the many moons of the gas giant Jupiter, named that way because they were large enough for Galileo to spot them through his telescope. Europa is the smallest of the 4, but is still only slightly smaller than our own moon, and about 1/4 the size of Earth. Significantly though, this unassuming, far-off world is thought to contain vast oceans of water around 10 to 15 miles below its icy surface. Scientists even estimate that it could hold roughly double the total water content of our own planet, with seas that are 40 to 100 miles deep. All of which means that Europa has long been considered one of the most likely places to find extraterrestrial life in the solar system. So if it's already a contender to host life, could humans one day live there as well? If life does exist on Europa, and there's no proof that it does at the moment, it's thought that it would probably be bacteria or single-celled organisms, which are generally much more resilient than human beings. Humans, by contrast, need a number of conditions and criteria to be met before there's even a chance of survival. Europa could naturally provide us with water to drink, but we also need air to breathe, food to eat, and reliable shelter. And that's just the basics. We also need to think about surface temperatures, air pressure, the strength of gravity, and the makeup of the atmosphere. We need to maintain an internal body temperature of 37 degrees Celsius, and we need to feed our bodies with just the right balance of nutrients. With all of that considered, there aren't any places in the solar system where we could just land, disembark, and immediately start setting up base. But Europa offers more potential than most to terraform. Crucially, Europa does have an atmosphere, and even better, that atmosphere is solely made up of oxygen. But unfortunately, it's also much too thin for humans to breathe. Still, the fact that there is a small amount of oxygen is a very good start, and something that already sets Europa apart from a lot of other planets and moons, along with the water. In theory, were we to terraform, we'd only need to harness and create more oxygen, in as safe a way as possible. However, the thin Europa atmosphere in part explains arguably the most dangerous part of any potential mission there, the radiation. The surface of Europa is pelted with about 540 rem daily, comfortably enough to kill a person very quickly. So much so, the threat of radiation poisoning is pitched as the biggest reason why Europa perhaps isn't suitable for human habitation, period. But in a future world where astronauts can feasibly travel to Jupiter in the first place, there could be a couple of ways to bypass this obstacle too. We could either try building very thick, ultra-advanced protective shields on the surface, or we could use Europa's own icy shell as a protective barrier by living below it. The ice would be thick enough to block out the radiation, which is one reason why scientists think there already could be life in the water below. True, the idea of a far-off human outpost totally submerged in water and buried underneath 15 miles of ice isn't perhaps the most welcoming of mental images, but no one said this would be easy. Regardless, say we've mastered and enhanced Europa's oxygen and built a home beneath its radiation-defeating ice shelf. What then? Well, the gravity presents another obvious challenge. Europa's gravity is slightly weaker than our own moon's, and about 13% that of Earth. In the short term, it'd mean having to get used to floating about in low-gravity conditions. But in the long term, it poses greater problems for us as low gravity has been linked to weakening immune systems, lessening bone density, and bringing about muscle atrophy, among other things. Astronauts counteract these effects by using exercise machines and following strict exercise routines during stays on the International Space Station, for example. But were humans ever to permanently live with less gravity, it'd mean whole generations of people battling major and unprecedented health issues. So the water is fantastic, though it is thought to be salt water, so would need purifying. The atmosphere is also promising, the radiation not so much, but there are workarounds, and the gravity is a great, but potentially damaging unknown. The temperatures on Europa are another key hurdle on our prospective mission to live there. The surface sees temperatures ranging from -160 to -220 degrees Celsius, so even without the constant radiation threat, living on the surface isn't really feasible. Luckily though, the water where we'd be headed isn't nearly as cold, all of which raises all new questions on underwater settlements. Specifically, can we even build them? A growing number of architects think that we can, and some have even started to design underwater cities on Earth, like the pioneering Conshelf Stations 1 and 2, built in the 1960s. These types of projects are still in their very early stages even on our own planet, but by the time we've developed space travel techniques advanced enough to get people to Europa, perhaps we'd also have perfected underwater living as well. Let's not get too far ahead of ourselves though. Even in a reality where we really could live underwater en masse, the issues on Europa's surface wouldn't disappear. Ultimately, in the event that we successfully arrive at the far-off moon in the future, navigating the surface to get under the ice could still prove very difficult, but staying there, maybe not so much. Europa is by no means the perfect candidate for off-Earth living, but it does offer more than most other places, and there are even a couple of missions already aiming to place a colony on Europa, although none are past the research and development phase just yet. Could humans live on Europa? More and more people are claiming that it's possible. Right now, it's a matter of first getting there, second, surviving the surface, and third, adapting to life underground, underwater on a Jovian moon. It's certainly a long shot, but there are still plenty of reasons to regard Europa with particular interest.
Introducing the Solar System. It's home to Earth and 7 other planets, all cutting their cosmic path through space and zooming around the Sun. There's also the asteroid belt, various dwarf planets, and many, many moons. The gas giant Saturn plays host to a lot of those moons, and some of them rank amongst the most interesting worlds we know about so far. While not all of them have been officially confirmed, Saturn has 82 moons and counting. As our technology improves, we're discovering more and more objects orbiting this famously ringed world. But already some stand out as being particularly notable. Titan, for example, usually features at the top of the list whenever humankind is thinking about where it might want to move to next. Titan is Saturn's largest moon, and significantly, it has a dense atmosphere and surface liquid. Both of these things combined mean that it could one day be a habitable destination for off-Earth human colonizers. Or, if alien life does exist in the solar system, then here is where it could be thriving. But while Titan tends to grab most of the headlines, Enceladus is another Saturnian moon that increasingly demands attention. It was discovered back in 1789 by William Herschel. Although so much of the detail we know about Enceladus today comes from the groundbreaking Cassini probe, which performed multiple flybys of this most enigmatic of moons between the years 2005 and 2015. With a diameter of just over 300 miles, Enceladus is about 10 times smaller than Titan is. On the surface, it's ice for as far as the eye can see, resulting in this moon usually being labeled as the most reflective astronomical object in the entire solar system. Out here, we're about 900 million miles away from the Sun, but even so, most of the little light that does reach Enceladus is bounced back out again. However, though it hangs marble-like in space, Enceladus isn't smooth. There are craters pockmarking its surface, but also deep and wide-reaching trenches and chasms. The most famous of these are known as the Tiger Stripes, located near the moon's south pole. Again, most of what we know about them comes from observations made by the Cassini probe. And while scientists are still trying to work out exactly what the stripes are, we do know that there are 4 of them. They're around 80 miles long and more than 1 mile wide on average. They're a third of a mile deep, and they're active. We know that Enceladus as a whole is a geologically active world, unlike many of the solar system's other moons. But this region is more so than most. There are streams of gas, vapor, and dust shooting out of the Tiger Stripes. as modern astronomers look to them as one of the best examples that we have of cryovolcanism in action. The tiger-striped streams are thought to originate from a sub- but near-surface ocean, and the watery vapors and gas they produce are believed to be vital to the Saturnian system because they contribute to the chemical makeup of Saturn's E-ring, the widest of all the rings circling it. This moon Enceladus is more than just a satellite orbiting a planet then. It's actually crucial to that planet's iconic look and composition. But still, regardless of the function they have now, the tiger stripes have been a source of much discussion since they were first observed in detail in the mid-2000s. These unusual features get their name mostly thanks to how regular the pattern they create appears to be. These are huge, miles-wide cracks in the surface, but from far away they look almost like deliberate scratch marks, or the striped pattern of a tiger's coat. So what's going on? Naturally, as whenever something strange emerges in space, one answer put forward as to why the tiger stripes are there is aliens. That some kind of extraterrestrial presence could have somehow built or caused them. This isn't the answer that most scientists give, but the seeming symmetry and even spacing between the tiger stripes may have led to some of the more speculative fringe theories. But really, even without the suggestion of an intelligent alien influence on them, the search for alien life does at least have an interest in the tiger stripes. That's because these massive visible cracks could one day provide us with a route to the water just beneath Enceladus's surface. And alien microbes could, according to some theories, be hiding there. In reality, though, the stripes formation has to do not with alien activity, but with chance physics. A study by researchers Douglas Hemingway, Maxwell Rudolph, and Michael Manga, and published in late 2019, found that these unusual trenches will have most likely opened up in Enceladus's history thanks to gravity. Two things are happening. One, as Enceladus moves around Saturn, it's subject to tidal forces that gradually pull at the moon and heat it up. Two, because the surface ice on Enceladus is thinnest at its poles, here's where the greatest impact of those tidal forces is felt. It's thought that the subsurface waters will have thawed, refrozen, and expanded over time, until one day when they burst out of the icy ground above. This is how it's believed that the first tiger stripe was formed. From there, material from the subsurface ocean had a direct route to above the surface, which it took before settling back down on the surface, thereby adding weight and increasing pressure until the next crack opened up and the next stripe formed. Then the same thing happened for the third stripe and for the fourth. This may have taken place quickly or gradually, but it will have amounted to a kind of ripple effect across Enceladus's surface, the results of which we see today. Still, the question as to why the tiger stripes appear precisely where they do has continued to bug scientists. In the 2019 Hemingway, Rudolph, and Manga study, one implication was that the cracks could just as easily have formed at the moon's north pole, rather than the south. However, an August 2020 study, led by the planetary scientist Alyssa Roden, suggested that the stripes to the south may not have been quite such a chance event. The broad idea put forward by this new approach was that the ice to the north may actually be notably thicker, and maybe even 2 or 3 times as thick as the ice in the south is. Meanwhile, computer modeling found that the ice in the south may need to have been less than 3 miles thick to allow for the first stripe to form. All of which means that Enceladus's subsurface ocean could, in reality, be extremely close to the surface, and within touching distance in cosmological terms. So why do these strange marks on a moon that's almost 1 billion miles away from Earth matter? It boils down to us human beings striving to understand the solar system in better ways. We've known that Enceladus is there for more than 230 years, but it's only relatively recently that we've been able to explore. And because of the subsurface ocean that it has, it remains a main site of interest on 2 fronts: in the search for alien life and the search for potentially hospitable future human homes. So now, imagine a future time when we do have the technology enough to pay Enceladus a visit, when space travel has advanced to the point that 1 billion miles is a genuinely manageable distance for humans. Where's the first place we're likely to land? If we can gather enough background knowledge on the tiger stripes, then it could be them that we see outside our spaceship window when we make our first approach. Between now and that hypothetical time ahead, there's clearly so much that we need to achieve. The pioneering Cassini mission was ended on September 15, 2017, when the probe was deliberately driven into Saturn's atmosphere and destroyed. But the good news is that there are plans for future missions to further improve our knowledge and understanding. However we get there, though, let's hope that we do get there soon, because Enceladus is rapidly emerging as one of the solar system's most intriguing destinations. And the tiger stripes are its main attraction, even if they probably weren't caused by aliens.
Earth's evil twin is about the same size and mass, but it has an incredibly toxic atmosphere full of heavy CO2, scorching temperatures, and acid rain. Venus is so inhospitable that we gave up on sending probes out there before the turn of the century. However, plenty of evidence suggests that it wasn't always this way. The surface of Venus is hostile to life as we know it. Its atmosphere is made up largely of 96.5% carbon dioxide, and is so thick and heavy that the atmospheric pressure at its surface is 92 times stronger than Earth's. That means that walking on Venus would be like walking on the seafloor 3,000 feet down, through an ocean made of sulfuric acid at temperatures exceeding 880 degrees Fahrenheit. Every other planet in our solar system is inhospitable to us without some significant tweaking. However, Venus's rotation also sets it apart. Like Uranus, it rotates in the opposite direction to the other planets in the solar system. Its rotation is also extremely slow. A day-night cycle on Venus takes 116.75 Earth days. At least Venus's gravity is something we don't have to worry about. Its gravity is 8.87 meters per second squared, only slightly less than Earth's. While today its size and gravitational pull are the only things similar to our own planet, scientists have used these similarities to suggest that once upon a time, Venus was capable of supporting life. A NASA study showed that in computer models that assumed various levels of water coverage, Venus could have sustained liquid oceans for 2 to 3 billion years of its 4.5 billion year lifespan. Considering Mars only had liquid water for 400 million years, Venus is a much likelier candidate for hosting alien life. In these simulations, it was found that temperatures on Venus ranged between a relatively comfortable 68 to 122 degrees Fahrenheit. That's about the same temperature as parts of Earth close to the equator, where humans have been living for thousands of years. So it's definitely possible for life, including intelligent life, to develop in these conditions. This revelation has led to a change in our understanding of what kind of planets may be habitable outside of our solar system. Previously, the Venus zone was thought to be a region of space where there was simply too much solar radiation to maintain liquid water. But now we have many reasons to believe that this isn't true. This means that lots of exoplanets we've discovered and written off as being outside of what we consider to be the Goldilocks zone might harbor extraterrestrial life after all. This not only increases our chances of discovering alien life, but also of one day finding a second home for humanity if we need to. These Venus zone planets might be a little warmer than we're used to, but if they can sustain a decent amount of liquid water for billions of years, then they're definitely worth our time. But if Venus might have once been capable of supporting life, what made it the toxic wasteland it is today? Scientists don't have a solid answer for this. One popular theory is that Venus experienced an outgassing, a volcanic event that led to a huge outpouring of poisonous gases like CO2 and a runaway greenhouse effect around 715 million years ago. Venus has active volcanoes to this day. The dense atmosphere and high volume of CO2 could be evidence of an apocalyptic period of Venusian warming. With climate change one of the most pressing issues facing mankind, understanding how Venus came to be this way could help us prevent the same thing from happening to Earth. If they were identical twins once, they could become identical twins again, and not by way of Venus's clouds dissipating and allowing alien life to thrive. Then again, other theories say that Venus's liquid ocean may have also been its downfall. Unlike Earth, Venus doesn't have any moons, but if it once had water, it would still have a solar tide controlled by the sun's gravity. Some evidence suggests that tides can actually slow the rotation of a planet down. In 2019, researchers at Bangor University in Wales argue that this may have occurred on Venus, causing its incredibly slow rotation and resulting in the planet becoming uninhabitable. One barrier to further study is the fact that Venus's surface is only 500 million years old, so it formed after the planet was already hostile to life. While Venus's clouds might be full of sulfuric acid, the space above the clouds has often been suggested as the site of a potential human colony. About 30 miles over the planet's surface, the pressure is similar to Earth's at sea level, and the temperature drops to 140 degrees Fahrenheit. Besides being friendlier to humans, though, these clouds could be the last refuge of any life that may have existed on the planet. Sturdy microbial creatures could be living in those clouds quite happily. We know that some organisms can thrive in extreme conditions on Earth. Tardigrades, for example, can survive in temperatures ranging from minus 328 degrees Fahrenheit to 300 degrees Fahrenheit, and our own clouds are home to all kinds of microbial life forms. So clouds, thin and light as they may be, are ecosystems all of their own, and Venus's might just be the same. It's also possible that such organisms could have spread to Venus from Earth. Rocks ejected by Earth, by violent impacts for instance, could have reached Venus before, just as Venusian materials could have reached our own modest shores. This means that an interplanetary migration of small organisms could have taken place in the past, and that humans are naturally Venusian in origin, or that Venusian life forms are descended from Earth. It's equally possible that both planets had life seeded on them from another body in the solar system, and that these life forms evolved completely separately on neighboring planets for billions of years, before Venus was devastated by greenhouse gases. We won't know for sure until we study Venus further, but it's definitely possible that our microscopic ancestors came from another world. In the wake of revelations about Venus's part, interest in our twin planet has grown. While NASA hasn't sent a probe to Venus since 1994, they and other space agencies are planning to change this. The European Space Agency and Indian Space Research Organization are making plans to launch orbiters, and Roscosmos is looking into an orbiter, lander, and research station to analyze Venus's surface, volcanoes, and weather conditions. While we don't have plans to try and send humans to Venus anytime soon, we'll definitely learn more about what makes this strange planet tick across the next few years. We don't know for sure whether life once existed on Venus, but we do know that it could well have had liquid oceans and been habitable for billions of years.
If you could travel in space, where would you go first? The Moon? Mars? The many moons of Uranus? Well, in a future reality where spaceflight is possible for all, there's something of a bucket list of tick-box travel destinations waiting for you to explore, which is what we're going to do today. The original 7 wonders of Earth date back to a list compiled in the 2nd century BCE, which included such legendary places as the Hanging Gardens of Babylon and the Colossus of Rhodes, plus the only structure still standing today, the Great Pyramid of Giza. A new list of wonders was more recently created, featuring amongst others the Great Wall of China, Petra in Jordan, and Christ the Redeemer in Brazil. But really, why stick to just this planet? The wider solar system has plenty to offer. And while there's no official list just yet, the 7 places or things we're about to explore do almost always feature whenever the topic is debated, including most famously as part of a 2010 documentary shown on history. So, in no particular order, first up, we have the Rings of Saturn, a celestial spectacle that it's almost universally agreed is deserving of the Wonder tag. Saturn isn't the only planet with rings, of course. Jupiter, Uranus, and Neptune have them too, but Saturn's are so spectacular that they've become a defining characteristic of the planet. The rings are formed from pieces of asteroid, disintegrating comets, and debris from moons, plus general space dust that has gotten stuck in orbit around the gas giant. There are 8 main rings in total, as well as the fainter Phoebe ring, more recently discovered, although there are various smaller rings in the gaps between these markers. Each ring also moves independently of each other, with them traveling all around Saturn at different speeds. It's a cosmic balancing act around this particular world, and a majestic part of space. Not far from Saturn is our next wonder, the Saturnian moon Enceladus. It's covered in thick ice, and because of this, bounces most of the sunlight that reaches it back out into space, making Enceladus one of the most reflective objects in the solar system. After years of speculation, The presence of subsurface liquid water on Enceladus was proven in 2014 by NASA's Cassini spacecraft. It was an extremely important discovery, confirming the Moon as one of the most likely places in the solar system, other than Earth, to support life. Enceladus also has a role in forming the rings of Saturn, specifically the E ring, thanks to eruptions from the ice volcanoes or geysers on its surface. These volcanoes shoot out water vapor and ice particles with such incredible force that they've essentially fed the E ring into being, while some of the erupted material falls back to Enceladus as snow. Much of what we know about Enceladus so far does come from the Cassini probe, but it's a sure bet that this moon will continue to be a key solar system location for us in the future. Saturn's neighbor, Jupiter, is home to our next wonder, the Great Red Spot. This is the largest storm in the solar system, with a diameter far larger than even Earth's is. The Great Red Spot is visible to us with a sharp enough telescope. But what makes it truly amazing isn't simply its size. It's also the fact that scientists have been watching it rage non-stop for close to 200 years now. And most researchers think it's been a feature on Jupiter for even longer than that. Massive clouds inside the spot create destructive cyclones and hurricanes, stretching for more than 10,000 miles across the Jovian surface and penetrating some 300 miles down into the atmosphere. This storm is so strong that its power can be felt from space itself, as its gravitational pull reportedly affected the flight path of the Juno probe when it passed Jupiter in 2019. Interestingly, however, the storm does appear to be shrinking, but scientists are unsure whether it will disappear completely. The fourth solar system wonder can be found much closer to our home, on a planet we might reasonably call home in the future, Mars. The red planet has a number of massive volcanoes scattered across its surface, but the Olympus Mons, named after the towering Mount Olympus in Greece, is the largest of them all, and also the most massive volcano and mountain found anywhere in the entire solar system. This colossal natural structure rises so high from the Martian surface that it's measured to be 2.5 times the size of Mount Everest, the tallest mountain on Earth. Olympus Mons is surrounded by unique cliffs that are 5 miles tall in themselves, while the volcano, as a whole, covers an area of Mars that's about the size of Italy. It's just a staggering landmark. The leading theory as to how it's been able to grow so big is that because Mars doesn't have plate tectonics, lava has just continually erupted from the same spot over and over again. And that lava has been solidified into rock, layering on top of itself, getting taller and taller. What's more, some believe that Olympus Mons is still young and could still be active, meaning it may grow to an even larger size in the future. Next up, we head right to the center, to the surface of the Sun, our next wonder of the solar system. And for plenty of reasons. For one, the Sun provides all of the light for the solar system, and without it, everything would just be dark. It also dictates the gravity that keeps everything in orbit, and it provides the general energy for life on Earth to exist too. The Sun is so massive that it takes up 99% of the solar system's total mass, and for its surface especially though, one layer of it, the photosphere, is around 300 miles thick. It's also so hot at around 10,000 degrees Fahrenheit, 5,500 degrees Celsius, that according to NASA, it wouldn't just melt diamond, it would actually boil it. The Sun's surface is far from stable, however, hosting, as it does, massive temperature fluctuations and sunspots, all while it casts out blistering flares into space. The Sun is, then, a unique balance between the heavenly giver of life and a deadly ball of scorching nuclear fusion that could feasibly end us all at any moment. But onto our penultimate wonder now, the asteroid belt. It, too, could feasibly cause a disaster for us, but scientists are fairly sure we're safe from harm. Found between Mars and Jupiter, the asteroid belt cumulatively accounts for very little mass, but it's interesting because it works something like a waste bin for solar system things that might have been. The belt is thought to contain the remnants of some long-gone moons and possibly planets that broke apart over a 4.5 billion year history. The largest asteroid belt object, though, is the dwarf planet Ceres. One reason why the belt can be considered a wonder is perhaps the specific conditions needed for it to form at all. It's really thanks to Jupiter's position and Jupiter's gravity that the asteroids and dust within the belt have never coalesced into another, bigger, planet-like object. But what's even more remarkable is how lucky we are that the belt did form, because asteroids from it are thought to have accelerated evolution and life on Earth by delivering essential compounds and water to our world. And that's pretty wonderful, don't you think? But the last wonder, maybe unsurprisingly, is Earth itself. And while it might seem a little vain to include our own world, it's not difficult to see why so many wonders of the solar system lists do. The sheer odds of Earth seem impossible. A planet that's seemingly fine-tuned for life. It's just the right distance from the Sun. It has an atmosphere, a magnetosphere, the right chemical makeup, and it has liquid water, among other things. Earth has given rise to billions of different life forms over its history, from beings as small as single-celled bacteria to large dinosaurs and predators. Not to mention us, the super smart humans. There's rich diversity on Earth too, from arid deserts to frozen tundra to lush rainforests and sprawling cities. And then, of course, we have the oceans. So far, Earth is the only place in the universe where we know life has developed. Too, that could change. But for now, it's a truly special place. It's easy to see why the destinations we've been to are those which most often come up whenever there's talk of the most magnificent and awe-inspiring solar system places. They're the most widely credited with wonder status. But if you could add something else, what would you choose? What's your favorite thing about our particular part of the universe?